Today, I'll examine how technology is managed in the modern enterprise, with a focus on robotics and artificial intelligence. These technologies are creating new possibilities for businesses, but adopting them also brings practical challenges. Organizations must consider how new tools fit into existing operations, how people adapt to changing ways of working, and how technology supports broader business goals. The central theme is the balance between technological opportunity and the realities of adoption in today's business environment. Throughout, I'll connect these issues to key concepts in business environments and management. Technology is no longer simply an opportunity for businesses. It has become a matter of survival. Organizations that delay adopting emerging technologies risk losing ground to competitors that can move faster and operate more efficiently. Two forces are especially prominent in today's boardroom discussions. Robotics automates physical and repetitive tasks, helping organizations streamline execution. Artificial intelligence extends human capabilities by augmenting decision-making and cognition. Together, these technologies are reshaping how work gets done, how decisions are made, and how companies compete in an increasingly dynamic environment. Today, I'll examine the main barriers organizations face when adopting intelligent technologies. We'll begin with financial and capital barriers, including the significant cost of acquiring and implementing new systems. Then we'll consider workforce and cultural resistance, focusing on the human factors that can slow or derail adoption. We'll also look at the technical challenge of integrating new tools with legacy infrastructure, along with the ethical, legal, and regulatory issues that intelligent systems create. Finally, we'll connect these challenges to strategic adoption frameworks that help leading firms manage change successfully. The first challenge is financial and capital barriers. The investment begins with significant upfront costs. Industrial robots can average between $50,000 and $150,000 per unit, even before installation, programming, and maintenance. The costs also continue after deployment. AI systems require ongoing data infrastructure, cloud computing, and model retraining, so expenses can compound over time. Finally, ROI is often difficult to predict. For many firms, especially with AI, the value may be indirect or take years to appear, making the business case harder to quantify and approve. This challenge is fundamentally about people, not just technology. Workforce resistance and the skills gap can derail implementation, even when the system itself is sound. Employees may fear displacement, which lowers morale and cooperation. At the same time, organizations may lack the internal expertise to operate, maintain, or improve AI-driven tools. Cultural inertia adds another barrier, especially when managers feel new systems threaten established routines or authority. The practical lesson is clear. Res-killing must begin before deployment and continue throughout implementation, not be treated as an afterthought. This challenge is technical complexity, specifically the difficulty of integrating modern AI and robotic systems with legacy infrastructure. Older software, databases, and machinery often weren't designed to communicate with one another, creating data silos and limiting access to the full picture. Proprietary systems may not offer open APIs, while retrofitting can cost nearly as much as adopting new technology. The painful paradox is that the businesses most in need of modernization often face the greatest friction. A practical assessment includes a data audit, mapping integration points, exploring an API bridge, and starting with a focused pilot. This challenge centers on the ethical, legal, and regulatory risks that arise when AI influences important decisions. Algorithmic bias is a central concern. If training data reflect discrimination, the system may reproduce in areas such as hiring, lending, or customer service, creating both social harm and legal exposure. Privacy is another issue, with regulations like GDPR and CCPA governing how personal data is collected, stored, and processed. Finally, accountability can be unclear when an autonomous system causes harm, especially when responsibility may involve the firm, a vendor, or the algorithm itself. This slide focuses on designing the human-technology relationship around partnership, not substitution. The most effective deployments augment human workers rather than replace them, freeing people to focus on judgment, creativity, and other higher value work. That principle leads to collaborative intelligence. AI surfaces relevant insights, while people interpret them and make decisions in complex or ambiguous situations. Fully automated systems may struggle when context matters. Finally, organizations need continuous reskilling, treating workforce development as a strategic asset and building AI literacy across every level of the company. Successful adoption rarely comes from a big bang deployment. Instead, high-performing organizations use a staged framework: pilot, evaluate, scale, and optimize. They begin with a small proof of concept, then measure both return on investment and workforce impact. If the results are promising, they expand through a phased rollout supported by targeted training. Finally, they continue improving through iteration and feedback. The foundation is clear from the start. Define the business problem, establish success metrics up front, and use what the organization learns to guide each next step. These examples show that AI delivers the most value when it augments human judgment rather than simply replacing people. Amazon's more than 750,000 warehouse robots work alongside a growing human workforce. In healthcare, AI tools help radiologists spot anomalies, while physicians remain responsible for care decisions. Financial firms use algorithms for real-time risk and fraud detection, but a 2010 flash crash showed how automation can amplify systemic risk. And Tesla's early production bottlenecks demonstrate the danger of automating faster than workers can troubleshoot and adapt. The key takeaway is that technology adoption is a strategic challenge, not merely a technical one. Sustainable success requires alignment across people, processes, and platforms, while anticipating financial, cultural, and regulatory friction. The strongest results come from human-AI collaboration, amplifying human judgment and creativity rather than replacing it.